At night, far from the shore, the ocean seems endless. From the surface, it appears calm and almost motionless, a vast, dark expanse of water, gently rippling in the wind. Sometimes the moon illuminates the long lines of waves. Sometimes the surface absorbs the light completely, turning into a deep blackness. At such moments, it's easy to imagine the ocean as simply an empty space, vast and silent. But in reality, everything is completely different. Beneath this calm surface lies a world of incredible complexity, a world that lives by its own laws, constantly moving and changing. Vast currents slowly transport billions of tons of water across the oceans. Invisible boundaries separate the different layers of the sea. Millions of creatures, from microscopic plankton to giant whales, create ecosystems that span the entire planet. The ocean covers more than 70% of the Earth's surface. It is the largest habitat on our planet and one of the main factors shaping its climate. It distributes heat between continents, influences weather, and supports life on a global scale. However, despite its enormous importance, the ocean remains one of the least explored places on Earth. Modern satellites can create detailed maps of the surface of Mars. Spacecraft explore distant planets and asteroids. Telescopes allow us to observe galaxies billions of light years away. But a significant portion of our own planet's seafloor remains unknown. The reason is simple. The ocean is extremely difficult to explore. Water blocks radio signals, making communication with underwater vehicles difficult and limited. Light fades rapidly as one descends deeper. At depths of just a few hundred meters, sunlight almost completely disappears, plunging the ocean into permanent darkness. But the most serious problem is pressure. With every tens of meters, the water pressure increases. At a depth of 1 kilometer, it already exceeds 100 atmospheres. In the deepest trenches of the ocean, the pressure can reach over 1,000 atmospheres, a force capable of crushing most materials. Therefore, every deep-sea expedition requires sophisticated equipment and enormous resources. Even today, only a few submersibles are capable of reaching extreme depths. Yet, despite these difficulties, scientists are gradually discovering more and more amazing features of the ocean. Sometimes these discoveries concern living creatures adapted to the most extreme conditions. Sometimes they concern unusual geological structures on the seafloor. But sometimes researchers encounter phenomena that surprise even seasoned oceanographers. For centuries, sailors have told tales of strange events occurring in the ocean. They spoke of seas that suddenly began to glow at night, as if vast swaths of water were transformed into a soft blue glow. Of gigantic waves appearing out of nowhere and rising over 20 meters. Of strange sounds emanating from the ocean depths. For a long time, such stories were dismissed as maritime legends. During the Age of Discovery, many sailors' tales were considered exaggerations or figments of the imagination. But gradually it became clear that many of these observations were quite real. With the advancement of oceanography, satellite technology, and underwater vehicles, scientists have begun to document phenomena that previously existed only in travelers' tales. Vast luminous areas of the ocean do indeed exist. Giant solitary waves can suddenly appear in a calm sea, and strange sounds sometimes arise in the ocean depths, capable of traveling for thousands of kilometers. Some of these phenomena have a perfectly understandable explanation. Others have long remained a mystery even to science, and some continue to be studied today. The ocean's uniqueness lies in its exceptionally complex nature. Water temperature, salinity, pressure, current movements, and interactions with the atmosphere create conditions in which astonishing processes can occur. Sometimes these processes become visible on the surface. Sometimes they are hidden deep within, where they can only be observed with specialized equipment. But each time they remind us of how extraordinary the ocean can be. Today, scientists have far greater capabilities for observing the ocean than ever before. Satellites record changes in water color and the movement of massive currents. Autonomous underwater vehicles can explore the depths for months without human intervention. And sophisticated sensor systems can record even the slightest vibrations in the water. Thanks to these technologies, we are gradually beginning to understand the processes that shape the ocean's behavior. However, the more we learn, the clearer one thing becomes. The ocean still holds a huge number of secrets. Some phenomena occur so rarely that they can be observed only a few times per decade. Others cover vast areas and can only be seen from Earth orbit. And still others continue to amaze researchers with their scale and power. In this film, we'll embark on a journey through the strangest and most unusual phenomena in the world's oceans. We'll see an ocean that glows in the dark, waves that arise without warning, underwater rivers flowing along the seabed, and sounds whose origins once baffled scientists. Each of these phenomena reveals a new side of the ocean as a powerful, dynamic, and incredibly complex system. And perhaps by studying these phenomena, we can better understand not only the ocean, but also the planet on which we live. Because despite all the advances of science, the ocean remains one of the last truly mysterious places on Earth. And its most amazing secrets are just beginning to be revealed. Sometimes the ocean starts to glow at night. This isn't the soft shimmer of waves near the shore you might see on tropical beaches. It's a much stranger and more widespread phenomenon. Imagine a dark ocean stretching beyond the horizon, and suddenly a vast expanse of water begins to emit a steady, milky blue light. Not isolated flashes, not sparks on the waves, but a calm, uniform glow, as if the entire surface of the sea has been transformed into a gigantic luminous field. Sailors have encountered this phenomenon for centuries. Some of the earliest descriptions date back to the 18th century. Captains of merchant ships crossing the Indian Ocean sometimes reported nights when the ocean around their ships became unusually bright. They said the water glowed so uniformly that it seemed as if the ship were sailing not on the sea, but on a vast, glowing lake. For a long time, such stories were met with disbelief. Many scientists dismissed them as exaggerations or optical illusions. After all, sailors spent months, sometimes years, at sea. Fatigue, fog, the play of light and waves, all of these could create strange visual effects. But gradually it became clear that we were talking about a real phenomenon. In oceanography, it was called milky seas. Milky seas. The name wasn't a coincidence. Eyewitnesses described the water as being slightly turbid, yet simultaneously glowing from within. The light didn't come from isolated points or flashes, but was spread evenly across the vast ocean surface. The most surprising thing about these observations is the scale. Sometimes luminous patches of water could cover thousands of square kilometers. There is evidence of individual milky seas encompassing an area the size of a small country. Ships could remain within such a luminous field for hours and sometimes entire nights before emerging from it. One of the most famous sightings occurred in 1967. A British ship was crossing the Indian Ocean off the coast of Somalia. In the middle of the night, the crew noticed the ocean around the ship gradually changing color. At first, the water appeared slightly lighter than usual, but after a while, The entire area around it transformed into a softly glowing surface. According to the captain, the light was so uniform that even the shadows of the ship's structures became visible on the water. This phenomenon continued for several hours. It was only in the morning that the ship finally emerged from the glowing patch of ocean. For a long time, such cases remained a mystery. Scientists understood that bioluminescent organisms, creatures capable of producing light, existed in the ocean. But these organisms typically produce short flashes of light caused by water movement. The glowing seas looked completely different. Their glow was steady and uniform, the water glowing even when its surface remained almost motionless. The answer to this mystery began to be found only in recent decades. Modern research has shown that the source of light in such cases is bioluminescent bacteria. These microscopic organisms are capable of emitting light thanks to a special chemical reaction occurring within their cells. When such bacteria gather in large numbers, they can create an effect that is noticeable even from a great distance. However, one question remains. Why do these bacteria begin to glow simultaneously and over such a large area? One possible answer involves a mechanism called quorum sensing in biology. Sensing is a unique form of collective microbial behavior. When bacteria reach a certain density, they begin to activate bioluminescence processes synchronously. In other words, billions of microscopic organisms can begin to glow almost simultaneously. This turns entire areas of the ocean into giant glowing fields. Interestingly, such phenomena are most often observed in the Indian Ocean and some areas of the Pacific Ocean. Scientists suggest that special conditions, a combination of water temperature, currents, and nutrients, exist there that allow bacteria to multiply rapidly. But even today, seas of milk remain a rare and difficult to predict phenomenon. Sometimes they appear suddenly and disappear within a few hours. Sometimes they can persist for several days in a row. And sometimes they are observed only once every few years. Modern satellites have begun to play an important role in studying these phenomena. Some are capable of detecting the faint glow of the ocean at night. Thanks to this, scientists were able to observe the milky seas for the first time, not only from ships, but also from space. On satellite images, they appear as huge bright spots on the surface of the dark ocean. One such observation occurred in 2019. Satellites discovered a vast glowing region in the Indian Ocean, covering an area exceeding 100,000 square kilometers. It was one of the largest recorded seas of milk in recorded history. For oceanographers, such events are of great interest. They allow us to better understand how microscopic life forms can influence entire ocean ecosystems. But for sailors who find themselves in the midst of such a phenomenon, the impression remains primarily emotional. Many describe this moment as one of the strangest and most beautiful things one can experience in the ocean. The night water begins to glow softly, as if the vast surface of the sea is filled with a cool blue light. And at this moment, it becomes especially clear how unusual the ocean can be. He is capable of creating phenomena that appear almost fantastical, but at the same time remain the result of complex and amazing natural processes. And the luminous seas are just one of these phenomena. Because in various corners of the world's oceans, events sometimes occur that until recently seemed impossible. Sometimes water begins to flow across the ocean floor like a river. Sometimes waves grow as tall as a multi-story building. And sometimes the sea surface itself begins to behave as if powerful, invisible forces were lurking beneath. And each of these phenomena reminds us that the ocean remains one of the most mysterious parts of our planet. At first glance, the ocean appears to be a single, continuous expanse of water. When we look at the sea from the surface, It's difficult to imagine that within this vast mass there could exist distinct currents, boundaries, and even structures resembling familiar natural landforms. But in the depths of the ocean, something amazing sometimes happens. There, you can see a phenomenon that seems almost impossible: rivers flowing along the seabed. For someone observing this phenomenon for the first time, the scene can seem completely surreal. A submersible slowly descends toward the seabed. A spotlight illuminates the uneven surface. Sand, rocks, and occasionally rare life forms adapted to life at great depths. And suddenly a dark stripe appears in the beam of light. It meanders along the bottom like a regular riverbed. Along its edge, a distinctive bank can be seen, separating one stream of water from another. And within this riverbed, a denser liquid slowly flows, resembling a murky underwater river. At first, researchers thought such observations were an instrumental error or an optical effect. After all, water shouldn't form rivers within itself. However, further research confirmed that such structures do indeed exist. One of the most famous places where underwater rivers can be observed is the Gulf of Mexico. Here, at a depth of about 1,000 meters, researchers discovered a remarkable formation known as an underwater salt lake. At the bottom of the ocean is a large depression filled with extremely salty water. This water is so saturated with salts that its density is significantly higher than that of the surrounding seawater. As a result, it doesn't mix with the surrounding water and forms a separate layer, resembling a real body of water. When underwater vehicles explore this place, it seems as if they are observing a real underwater landscape: the shores, the surface of the lake, and even small waves at its border. But even more surprising is that rivers sometimes flow out of such salt lakes and slowly move along the seabed. To understand how this is possible, we need to look at the properties of seawater. Although the ocean appears homogeneous, its water actually varies in several parameters: temperature, salinity, and density. Even small changes in these characteristics can create stable boundaries between different water layers. When water becomes significantly saltier, its density increases. This water tends to sink below less dense layers. In some regions of the ocean, this leads to the formation of peculiar currents that slowly move along the bottom like underwater rivers. Sometimes such currents are formed as a result of evaporation of water in hot seas. For example, in the Mediterranean Sea, intense evaporation makes the water saltier. When this water emerges through the Strait of Gibraltar into the Atlantic Ocean, it sinks to greater depths and begins to spread across the ocean floor. This current is known as Mediterranean deep water. It moves across the Atlantic for hundreds and even thousands of kilometers. But in some places, the difference in density is so great that the boundary between the streams becomes almost visible. When underwater cameras capture such areas, it feels as if one river flows within another. The denser water forms a kind of channel that can meander along the bottom, creating turns and bends. Sometimes actual banks of sediment form along these streams. The heavier water erodes the sand and silt, gradually creating a riverbed resembling that of a normal river. Underwater canyons and valleys, formed by the movement of water, arise on the ocean floor. One of the most impressive examples is the underwater river in the cenote area, Angelita in Mexico. Although this site is not in the open ocean but in a deep karst system, it clearly demonstrates what an underwater river might look like. At a depth of about 30 meters, the water suddenly becomes murky and dark. A stream of denser liquid passes through this murky boundary, creating the illusion of a real river with banks and even fog rising from its surface. Underwater rivers can exist not only as dense streams of salt water. Sometimes they are formed by massive masses of sediment. When sand and silt accumulate on continental shelves, underwater landslides can create powerful flows of sediment that rush down the ocean floor slopes. These flows are called turbidity currents. They can move at tremendous speeds, carrying millions of tons of sediment over long distances. These underwater rivers are capable of forming gigantic canyons on the seafloor, some of which are comparable in size to the largest canyons on land. One of the most famous is Monterey Canyon off the coast of California. It's over 3 kilometers deep and was formed by precisely such sediment flows. But perhaps the most amazing thing about underwater rivers is that they create special ecosystems. Unique life forms can exist at the boundaries between different layers of water. Some organisms have adapted to live in precisely these conditions, at the interface between dense salt water and the surrounding environment. These places become a kind of islands of life on the seabed. Sometimes unusual creatures can be seen around underwater salt lakes, worms, mollusks, and bacteria that use chemicals from these waters to generate energy. Thus, underwater rivers not only shape the topography of the ocean floor, but also create unique conditions for life. Today, scientists continue to study these phenomena using autonomous underwater vehicles and deep-sea robots. Each new expedition reveals more details about how vast masses of water move in the ocean. And the more we learn about underwater rivers, the clearer one important idea becomes. The ocean is more than just a huge mass of water. It is a complex system of flows, layers, and boundaries in which processes occur that resemble familiar natural phenomena on land. But in the ocean, they take on a different scale. And sometimes water can actually behave as if beneath the surface of the sea there is a whole network of invisible rivers slowly flowing through the dark depths of the planet. For most of human history, sailors have known that the ocean can be dangerous. Storms whip up enormous waves. Winds can transform calm seas into turbulent chaos, and strong currents can carry ships hundreds of kilometers off course. But among all the stories of sea dangers, there was one type of wave that was long considered almost a legend. Sailors reported gigantic waves that would arise suddenly, without warning. These waves could rise significantly higher than those around them. Sometimes they appeared in the middle of a relatively calm sea, sometimes during a storm. But almost always, they seemed completely disproportionate to the surrounding waves. According to eyewitnesses, such waves could reach heights of 20 and sometimes even 30 meters. They appeared suddenly, rising like a huge wall of water, and crashed onto the ship with colossal force. For a long time, scientists were skeptical about such stories. According to classical models of ocean dynamics, waves on the sea surface are distributed fairly uniformly. Even during a severe storm, wave heights should remain within certain statistical patterns. The emergence of a single wave significantly larger than the rest seemed extremely unlikely. Therefore, many experts believed that sailors simply overestimated the height of waves or perceived ordinary storm waves as something more dangerous. However, evidence gradually began to accumulate that such phenomena were indeed occurring. During the 20th century, several large ships suffered serious damage in the open ocean under circumstances difficult to explain by ordinary storms. Sometimes enormous cargo ships returned to port with severely damaged superstructures, as if a gigantic mass of water had collapsed on them. What was particularly strange was that such damage sometimes occurred in conditions when the surrounding sea did not appear to be exceptionally rough. The turning point in understanding this phenomenon occurred in 1995. A high-precision wave measurement system was installed on the Draupner oil platform in the North Sea. These instruments were intended to record sea conditions and help engineers assess the platform's operating conditions. On January 1st of that year, the sensors registered something unexpected. Amidst the usual storm surge, a gigantic wave over 25 meters high suddenly emerged. It was significantly taller than the surrounding waves and had a characteristic shape, a steep front and a powerful crest. This moment became the first scientifically confirmed observation of the so-called giant wave, or rogue wave. From that moment on, the attitude of science towards the sailors' stories changed. It turns out that such waves do exist, and they can be much more dangerous than previously thought. Unlike ordinary storm surges, giant waves are the result of a complex interaction of several factors. Sometimes they form when waves moving in different directions overlap. Sometimes they are amplified by powerful ocean currents. One of the most famous places where such phenomena are observed is the Agulhas Current region off the coast of South Africa. Here, a warm current moves south along the continent, and strong winds often blow in the opposite direction. When storm surges encounter a powerful current, their energy can increase dramatically. In such conditions, waves of extraordinary height sometimes arise. Some of them reach sizes comparable to multi-story buildings. Modern satellites and oceanographic buoys are increasingly capable of recording such events. It is now known that giant waves occur much more frequently than previously thought. They can occur in a wide variety of parts of the ocean, in the Atlantic, the Pacific, and even in relatively small seas. For modern vessels, such waves remain a serious threat. Even large container ships can experience colossal loads if they encounter a sudden wall of water several dozen meters high. Therefore, engineers designing marine vessels and platforms today take into account the possibility of such waves. However, despite the development of science, giant waves remain a difficult phenomenon to predict. They can appear suddenly and disappear just as quickly, leaving behind only the memories of eyewitnesses and instrument data. For sailors who find themselves face to face with such a wave, this moment often becomes one of the most impressive and frightening in their lives. Imagine a dark ocean during a storm. Powerful waves swirl around you, but their height seems typical for bad weather. And then suddenly, a huge wall of water appears ahead, significantly larger than anything that was around a second ago. The ship has only a few moments left to meet this wave. Moments like these remind us how powerful the ocean's energy can be. And although modern science is gradually uncovering the mechanisms by which these giant waves are formed, the ocean is still capable of surprising us with phenomena that long seemed impossible. But sometimes the ocean's oddities manifest themselves not only in the movement of the water. Sometimes the ocean itself begins to emit sounds so unusual and powerful that they can be heard by scientific instruments thousands of kilometers away. And one of these sounds once presented researchers with a mystery that remained unanswered for a long time. The ocean appears quiet only on the surface. Standing on the deck of a ship, one hears the sound of the wind, the lapping of waves, and, occasionally, the cries of seabirds. But lower a hydrophone, a special underwater microphone, into the depths, and the ocean world begins to sound completely different. A huge number of acoustic events occur constantly underwater. Currents move, ice cracks, and bodies of water of different temperatures collide. Marine animals communicate with each other, emitting signals, clicking, singing, and even creating complex acoustic structures. In the depths, the ocean turns into a real soundscape. Some of these sounds are well known to scientists. Whale songs can travel thousands of kilometers. Dolphins use complex echolocation, creating a series of rapid clicks. Even shrimp can produce sounds so loud that entire colonies create a constant crackling sound, reminiscent of rain. But sometimes hydrophones pick up sounds that are difficult to explain. At the end of the 20th century, a network of underwater acoustic sensors located in the Pacific Ocean began detecting unusual signals. These sensors were initially installed not to study the ocean, but for another purpose: monitoring underwater nuclear tests. However, their sensitivity turned out to be so high that they began to record the natural sounds of the ocean. And it was thanks to these instruments that one of the most mysterious sounds in the history of oceanography was recorded in 1997. This signal was named bloop. It was unusual for several reasons. First, its volume was exceptionally loud. Researchers estimate the sound was so powerful that it was detected by sensors located more than 5,000 kilometers apart. Secondly, its acoustic structure resembled signals typically produced by living organisms. But if it were the sound of an animal, its source would have to be enormous, much larger than any known sea creature. When scientists first published data on the bloop signal, numerous hypotheses quickly arose. Some suggested the sound might be emanating from an unknown giant animal. Others believed it was the result of underwater volcanic activity. However, there was no precise answer at that time. Only several years later did researchers arrive at a more plausible explanation. By comparing the acoustic characteristics of the signal with other recordings, they discovered that bloop closely resembled the sounds produced by the collapse of massive ice masses. When giant icebergs crack or collide with each other, they can create powerful acoustic waves that travel vast distances across the ocean. It is likely that this very process was the source of the mysterious signal. But bloop wasn't the only strange sound recorded in the ocean. During those same years, hydrophones also detected other unusual signals. One of them was named Julia. This sound was also recorded in the South Pacific. Its source remained unknown for a long time, although scientists later suggested that it was also related to the movement of Antarctic glaciers. Another signal, known as upsweep, proved even more mysterious. It consists of a series of ascending beeps, repeating at regular intervals. This sound has been recorded by hydrophones for several decades, but its exact origin remains unclear. Some researchers speculate that upsweep may be related to underwater volcanic activity or the movement of tectonic plates on the ocean floor. But even today, this phenomenon remains a subject of research. The ocean is an ideal medium for sound propagation. Water conducts sound waves much more efficiently than air. This allows some signals to travel thousands of kilometers with virtually no energy loss. There's even a special layer of the ocean known as the SOFA channel. This is a zone where the speed of sound propagation reaches exceptional values. Sound waves entering this layer can travel vast distances, as if inside an acoustic tunnel. It is thanks to this channel that whales are able to communicate with each other over distances exceeding 1,000 kilometers. But this same mechanism allows researchers to record rare and unusual sounds that occur in the most remote corners of the ocean. Each such signal becomes a kind of clue, allowing scientists to understand what processes are taking place in the depths. Sometimes it's the movement of glaciers. Sometimes it's underwater eruptions. Sometimes it's complex interactions between currents and water layers. But sometimes the ocean still brings surprises. Every new signal recorded by hydrophones is a reminder that the ocean remains one of the most complex and least studied acoustic environments on our planet. Beneath its surface, countless processes are constantly taking place, many of which humans are only just beginning to understand. And if you listen carefully, the ocean really can tell you a lot about itself. Sometimes through quiet and barely audible sounds, and sometimes through powerful signals that travel across the entire ocean, as if reminding us of how vast and alive this world of water is. But sounds are not the only strange thing about the ocean. Sometimes the sea surface itself begins to behave unusually. Ships may suddenly slow, as if held back by an invisible force. The water around them remains calm, the wind remains steady, but the vessel's movement becomes unexpectedly heavy. This strange phenomenon has been known to sailors for over 100 years, and they call it dead water. Sometimes the ocean behaves strangely not only in the depths, but also on the surface. The sea may appear perfectly calm, a light breeze, gentle waves, a clear sky. Nothing foreshadows trouble. But suddenly the ship begins to lose speed. The engines are working as before. The sails are filled with wind. The navigation instruments show the correct course, but the ship seems to be encountering invisible resistance. It moves slower than it should, and at times almost stops. For sailors of past centuries, this phenomenon was a real mystery. In the age of sailing ships, captains sometimes encountered situations where a vessel would suddenly begin moving extremely slowly, despite a good wind. The seas remained calm, the current was not strong, but the ship seemed stuck in the water. Sailors described this state as if the sea was holding the ship. One of the most famous cases occurred in the late 19th century during the expedition of Norwegian explorer Fridtjof Nansen. His ship, the Fram, was sailing through Arctic waters when the crew noticed a strange phenomenon. Despite the strong wind, the ship made little progress. At times, the ship began to vibrate, as if something were holding it underwater. Meanwhile, the sea surface remained relatively calm. Nansen wrote in his diary that the ship felt trapped by an invisible force. Later, scientists began to study this phenomenon and gave it the name dead water or dead water. To understand how this effect occurs, it's important to remember that the ocean isn't made up of a single, homogeneous layer of water. In fact, it contains many layers, each with different temperatures and salinities. When fresh river water mixes with salty seawater, it creates areas of varying density. Lighter water can remain at the surface, while denser water can remain below. Sometimes a rather sharp boundary appears between such layers. Internal waves, powerful vibrations of the water that occur not on the surface, but deep within, form at the boundaries between the layers. These internal waves can reach significant sizes. They move with the ship and create additional drag. From the sea surface, it's almost imperceptible. But beneath the surface, complex water movements occur that literally pull the ship backward. Sometimes the effect becomes so strong that the ship's speed can decrease several times. The phenomenon of dead water is particularly common in areas where fresh river water meets seawater. For example, off the coast of Scandinavia or in the Arctic, where melting ice creates layers of less saline water. But similar conditions can arise in other parts of the ocean, where differences in temperature and salinity create stable boundaries between layers. Modern research has shown that internal waves generated in such conditions can be much more powerful than previously thought. Sometimes their height reaches tens of meters, although they are completely hidden beneath the surface. Such waves can pose a serious danger to underwater vehicles. They can dramatically alter water flow conditions and affect the stability of equipment. But for an observer on the surface, the ocean remains almost calm. This makes the phenomenon of dead water particularly unusual. It demonstrates how complex the processes occurring in the ocean can be. Even when the surface appears calm and predictable, powerful water movements can unfold beneath the surface. Today, oceanographers are actively studying internal waves using satellites and autonomous underwater vehicles. This research helps us better understand how energy propagates within the ocean and how it influences global currents. In some areas, internal waves play a vital role in mixing water and distributing nutrients. They create conditions in the ocean that support life at various depths. Thus, the phenomenon of dead water turned out to be not just a curious marine phenomenon, but part of a much more complex system of processes. But the ocean is capable of creating even more unusual pictures. Sometimes the water begins to move in such a way that giant rotating structures, whirlpools, form on the surface, which can reach tens of kilometers in diameter. These slowly rotating systems can last for weeks or even months, moving huge masses of water across the ocean. And when scientists first saw them from satellites, it became clear that the ocean possessed energy and dynamics that were difficult to imagine from observing the calm surface of the sea. When viewed from the surface, the ocean appears relatively calm and smooth. Waves rise and fall, the wind changes the direction of the currents, but all of this appears to be chaotic water movement. However, if you rise high above the ocean, for example, on board a satellite, you can see that the water moves in a much more organized manner. Enormous rotating structures resembling giant eddies can be found on the ocean surface. These formations can reach tens and sometimes hundreds of kilometers in diameter. They slowly rotate, moving enormous masses of water through the ocean. Scientists call them ocean eddies or mesoscale eddies. Essentially, these are giant rotating systems, similar to atmospheric cyclones, but formed in water. When researchers first began observing such structures from satellites in the late 20th century, they were astonished by their scale. It turned out that the ocean was literally covered in a network of slowly rotating eddies. Some of them last only a few days. Others can persist for months, gradually moving hundreds of kilometers. One of the most famous regions where powerful ocean eddies form is in the Atlantic Ocean off the coast of South Africa. One of the planet's strongest currents, the Agulhas Current, flows here. It carries warm water from the Indian Ocean south along the coast of Africa. When the current reaches the southern tip of the continent, it encounters the cold waters of the Atlantic. As a result of this collision, huge masses of water begin to swirl, forming giant vortices. Some of these vortices are so large that they can reach 300 kilometers in diameter. For comparison, this is greater than the distance between many large cities. These structures slowly rotate and move across the ocean, transporting warm water from one region to another. This plays a vital role in global ocean circulation and influences the planet's climate. But whirlpools don't only exist in the open ocean. Sometimes powerful eddies can form in narrower straits or fjords. In such places, they become especially noticeable and even dangerous to shipping. One of the most famous examples is the maelstrom off the coast of Norway. For centuries, sailors have told stories of a giant whirlpool that supposedly had the power to suck ships into the depths. These tales became part of maritime folklore and even inspired writers such as Edgar Allan Poe. In reality, maelstroms exist, but they are not as catastrophic as the legends described. However, in some places, currents and tides can indeed create powerful eddies. One of the most powerful whirlpools in the world is Saltstraumen, also located in Norway. During high tide, a huge volume of water flows through the narrow strait here. The currents collide and begin to swirl, forming eddies up to 10 meters in diameter. For small boats, such whirlpools can pose a serious danger. But in the open ocean, the eddies are much larger. Although they rarely pose a direct threat to large vessels, their impact on the environment is enormous. Eddies mix different layers of water, transport heat and nutrients, and create conditions favorable for the development of marine life. Sometimes entire ecosystems form within such whirlpools. Nutrients rising from the depths stimulate plankton growth. The plankton attracts small fish, which are then followed by larger predators. Thus, giant eddies become a kind of oasis of life in the ocean. Satellite observations have shown that such structures play a vital role in global ocean circulation. They help redistribute heat between different regions of the planet and influence climate processes. But sometimes vortices can also create unusual visual effects. On satellite images, they appear as enormous spirals on the water's surface. Sometimes they can even be seen from an airplane, especially when the vortex contains algae or floating debris. Then a giant spiral appears on the surface of the ocean, slowly rotating among the waves. Such images remind us that the ocean is more than just a vast body of water. It is a dynamic system in which complex water movements are constantly taking place. And although we cannot always see these processes from the surface, they play an important role in the life of the entire planet. But even giant whirlpools are only part of the amazing phenomena of the ocean. Sometimes strange occurrences are not caused by the movement of water, but by processes occurring at the very bottom of the ocean. There, in complete darkness, huge gas bubbles can suddenly appear, rising from the depths. And these processes can affect not only ocean ecosystems, but also the safety of ships passing over them. Far beneath the ocean surface, in the cold, dark depths of the seafloor, processes are taking place that humans long unknowingly defied. Where the pressure is enormous and the water temperature barely exceeds a few degrees, vast reserves of gas are hidden within the sediments. This gas is methane. It forms as a result of the decomposition of organic matter that has accumulated on the ocean floor for millions of years. The remains of plankton, algae, and other organisms gradually sink to the bottom, where in low oxygen conditions, bacteria begin to decompose them. Over time, this process produces methane, which can accumulate in marine sediments. Sometimes this gas remains bound to water in special compounds known as gas hydrates. In these structures, methane molecules are trapped within the crystal lattice of ice. Even though the surrounding water may be liquid, the gas remains locked within these compounds. Methane hydrates form under high pressure and low temperatures, conditions that are typical of the deep ocean. Scientists believe the seafloor contains vast quantities of these hydrates. Some estimates suggest their energy potential may exceed the combined reserves of all known natural gas deposits on land. But sometimes the stability of these connections is disrupted. Changes in temperature, pressure, or geological activity can cause methane to be released from sediments. When this occurs, the gas rises as bubbles. Sometimes these emissions are relatively small, but in other cases, entire fields form on the ocean floor, where plumes of gas bubbles constantly rise from the sediment. When a submersible passes through such an area, its floodlights illuminate a remarkable sight. Thousands of silvery bubbles slowly rising through the dark water, like an underwater rain of gas. However, sometimes the scale of these processes turns out to be much more impressive. Gas craters on the seafloor of several seas. These structures form when methane accumulated under sediments suddenly erupts. As a result, the seabed can literally rupture, leaving behind large craters. Similar processes are occurring on land as well. In recent years, giant craters formed by methane emissions from permafrost have been discovered in the Arctic regions of Siberia. On the seafloor, such phenomena may remain hidden, but modern sonar research has revealed many such structures. But methane emissions may be of interest not only to geologists, they also play an important role in marine ecosystems. In areas where methane emerges from the seafloor, specialized communities of organisms often form. Some bacteria are capable of using methane as an energy source. These bacteria become the basis of entire food chains. Around methane vents, you can find unusual worms, mollusks, and other creatures that have adapted to life in these conditions. These ecosystems resemble those that form around hydrothermal vents on the seafloor, places where life exists independently of sunlight. But methane emissions have another side. Sometimes they can create a potential hazard to ships. When a large amount of gas rises through the water column, it forms a mixture of water and bubbles. This mixture has a significantly lower density than normal seawater. If a ship is located directly over an area of intense gas emission, the water beneath it may temporarily lose its ability to support its weight. Theoretically, this could lead to loss of buoyancy. While such situations are considered rare, some researchers suggest that similar processes may have played a role in the disappearance of individual ships in the past. Sometimes this hypothesis is even linked to mysteries such as the Bermuda Triangle, where strange disappearances of ships have been reported. However, most scientists believe that such cases are extremely unlikely and require very specific conditions. Nevertheless, the study of methane emissions remains an important part of modern oceanography. Firstly, these processes help us better understand the geological activity of the seafloor. Secondly, they may play a role in global climate, as methane is a potent greenhouse gas. If large volumes of methane are released from marine sediments and reach the atmosphere, this could influence climate processes. Therefore, scientists closely monitor such phenomena. Today, autonomous underwater vehicles, sonar systems, and satellite technologies are used for this purpose. Each new expedition reveals more and more details about how the seabed is structured and what processes occur in its depths. And the more we learn about methane emissions, the clearer one important point becomes. Even in the darkest and coldest places of the ocean, processes occur that can affect the entire planet. Sometimes strange things happen right on the surface of the sea, when huge masses of water begin to move as if there is a gigantic energy hidden beneath them. And it is then that waves can appear that were long considered impossible. When we hear the word waterfall, we usually imagine a mountain river tumbling noisily over cliffs. The stream of water cascades down, crashes against the rocks, and turns into a cloud of spray. Such waterfalls can be found in the mountains or on the edge of deep canyons. But few people know that the largest waterfalls on Earth are not located on dry land. They are hidden beneath the ocean's surface. At first glance, this seems impossible. How can water fall inside other water? But in the ocean, there are conditions under which this actually happens. One of the most impressive examples is located in the North Atlantic between Iceland and Greenland. It is here that the largest waterfall on our planet is located, although it can only be seen with scientific instruments. This waterfall is known as the Danish Torrent Falls. Its height reaches approximately 3,500 meters. For comparison, this is almost 4 times higher than the famous Angel Falls in Venezuela, considered the tallest waterfall on land. But instead of a rushing stream of water falling from a cliff, something more complex is happening here. In this region, the cold, dense waters of the Arctic meet the warmer waters of the Atlantic Ocean. Because the cold water is denser, it begins to sink, like a heavy current. When these masses of water reach the edge of the underwater ridge, they literally spill over it, forming a giant stream that rushes into the depths of the ocean. The speed of this movement can reach several million cubic meters of water per second. If we could observe this phenomenon directly, the picture would be truly spectacular. A huge stream of cold water slowly falling down an underwater slope, forming a giant waterfall hidden in the darkness of the ocean depths. Although this process occurs at depth, it plays an important role in ocean circulation. As cold water sinks, it becomes part of a global current system known as the thermohaline circulation. This system transports water between different parts of the world's oceans and helps distribute heat across the planet. In fact, underwater waterfalls are one of the mechanisms that keeps this giant ocean conveyor belt moving. But there are also other underwater waterfalls that can be observed much closer to the surface. One of the most famous examples is the phenomenon off the island of Mauritius in the Indian Ocean. Viewing this stretch of ocean from the air reveals a striking sight. The water at the edge of the island appears to begin to flow downwards, forming a huge stream reminiscent of a waterfall. It seems as if part of the ocean is literally falling into a bottomless abyss. In fact, this phenomenon is an optical illusion. Off the coast of Mauritius, the seabed drops sharply. Streams of sand and sediment slowly move down this slope, creating the impression of water moving downward. When sunlight reflects off the various layers of water and sand, it creates the visual effect of a giant waterfall. While this phenomenon is not a true waterfall in the strict sense, it does demonstrate how unusual processes in the ocean can be. But real underwater waterfalls do exist. They are just hidden from human eyes. They can only be detected using sophisticated oceanographic instruments. Modern research shows that such currents play a vital role in mixing ocean water masses. They help transport cold water to the deep ocean and influence the distribution of oxygen and nutrients. Without these processes, many ocean ecosystems could not exist. Thus, underwater waterfalls are part of a huge circulation system that connects all the oceans of our planet. They work slowly, almost imperceptibly, but their influence extends over thousands of kilometers. Sometimes just a small change in temperature or salinity of the water is enough for such currents to begin to strengthen or weaken. And while most people will never see these waterfalls with their own eyes, they continue to work in the depths of the ocean, keeping giant masses of water moving. At a depth of several hundred meters, the ocean plunges into complete darkness. Sunlight gradually fades, absorbed by the water column. First, the red and yellow hues disappear, then the green. And at a depth of about 1,000 meters, the ocean becomes almost completely black. This is where the zone that oceanographers call the aphotic zone begins, the area where sunlight no longer penetrates. At first glance, it might seem impossible to live in this darkness, but it is here that one of the most unusual worlds on our planet begins. In the depths of the ocean, light still exists. Only it is not created by the sun, but by living beings themselves. Many deep-sea creatures possess bioluminescence, the ability to produce light through chemical reactions within their bodies. This light can be blue, green, or sometimes violet. To someone in the depths of the ocean, it would look like a strange underwater space. Tiny lights move slowly in the darkness. Short signals flash and luminous shapes appear and disappear. Sometimes it seems like there are little stars floating around. Some of the most famous inhabitants of these depths are anglerfish. These strange predators use a special luminous organ located at the end of a long projection on their head. This organ acts as a bait. In the complete darkness of deep waters, small fish and invertebrates may mistake the soft glow for a food source. When prey approaches, the predator instantly attacks. Thus, light becomes a hunting tool. But anglerfish are just one example. Some squid species are capable of creating complex light patterns on their bodies. These signals can be used for communication between individuals of the same species. In other organisms, light serves as camouflage. For example, some deep-sea fish emit a faint glow on the underside of their bodies. This helps them hide from predators looking up. The fish's glow matches the dim light coming from above, making the animal's silhouette nearly invisible. This method is called backlighting. There are also organisms that use light as protection. Some jellyfish and shrimp are capable of producing bright flashes when attacked by a predator. The sudden flash can disorient the predator or attract a larger predator, which will then attack the attacker. In the depths of the ocean, light becomes a universal language. It can warn, disguise, attract, and deceive. Research shows that bioluminescence is one of the most common adaptations of deep-sea organisms. By some estimates, over 70% of animals living in the deep ocean are capable of producing light. This turns the dark ocean waters into a complex and constantly changing light environment. But it is extremely difficult to observe this world. Even modern underwater vehicles face a problem. Bright spotlights can frighten deep-sea animals, causing them to disappear into the darkness. Therefore, scientists are increasingly using specialized cameras capable of operating in minimal light. Sometimes these cameras capture incredible scenes: transparent jellyfish slowly swimming through the darkness, the long, glowing tentacles of squid, or fish whose bodies are covered in rows of tiny lights. These shots are reminiscent of science fiction films, but all of this is happening in reality, in the depths of the ocean. Bioluminescence also plays an important role in the study of marine ecosystems. Some researchers use specialized devices that simulate animal movement and induce light reactions in plankton. These reactions can be used to determine the density of organisms and the structure of underwater communities. Thus, light becomes a tool for studying the ocean. But even today, we know only a small fraction of creatures capable of producing bioluminescence. Each new deep-sea expedition discovers new species and new forms of luminous organisms. Some of them look so unusual that they resemble alien creatures. And perhaps that is why many scientists say that if a person were to find himself in the depths of the ocean without equipment, he would see one of the strangest and most beautiful worlds on Earth. A world where darkness and light exist simultaneously. But the depths of the ocean hide more than just unusual life forms. Sometimes the waters themselves begin to move in such a way that phenomena of enormous scale arise in the ocean, so powerful that they can influence the climate of the entire planet. To understand these processes, we need to look at the ocean as a single system of giant currents connecting all the seas of the Earth. When viewed from the surface, the ocean can appear chaotic. Waves move in different directions, winds reshape the water, and storms occasionally transform the sea into a seething chaos. But beneath this apparent chaos lies one of the most complex and powerful water movement systems on our planet. The ocean is constantly in motion. It is traversed by gigantic currents, slow but incredibly powerful water flows that connect all of the Earth's oceans. These currents transport heat, salinity, oxygen, and nutrients over vast distances. They are sometimes referred to as the global oceanic conveyor belt. This system originates in the cold regions of the North Atlantic. Here, cold air cools the ocean surface. As the water cools, it becomes denser and begins to sink. This process creates a powerful current of deep water that slowly moves across the Atlantic Ocean. At this time, the reverse process occurs on the surface. Warm water from the tropics moves north, compensating for the sinking masses of cold water. One of the most famous currents of this system is the Gulf Stream. This current transports huge volumes of warm water from the Caribbean toward Europe. Thanks to this current, the climate of Western Europe is significantly milder than in other regions at the same latitude. For example, London is at the same latitude as southern Canada. But thanks to the warm waters of the Gulf Stream, winters there are significantly milder. Thus, the ocean plays a key role in shaping the climate of our planet. But ocean currents are important for more than just climate. They also influence the distribution of life in the seas. When cold, deep water rises to the surface, a process known as upwelling, it brings with it nutrients stored in the deep ocean. These substances become food for microscopic plankton. Plankton, in turn, forms the basis of the entire marine food chain. Where upwellings occur, some of the world's richest fisheries often emerge. This is why many large fishing grounds are located in areas where deep waters rise to the surface. But the movement of ocean currents does not only occur on the surface. Deep underwater, there are currents that can travel thousands of kilometers. Some of them originate in Antarctica, where cold, dense water sinks to the ocean floor and slowly spreads across the planet. This process can take hundreds of years. Water that is currently sinking into the ocean depths off the coast of Antarctica may only reach the North Pacific Ocean in a few centuries. Thus, the ocean becomes a giant circulation system connecting all the seas of the Earth. But this system is not permanent and unchanging. It can respond to changes in climate, temperature, and atmospheric composition. Some scientists suggest that changes in global ocean circulation could significantly affect future climate processes. If major currents weaken or change direction, this could lead to significant temperature changes across different continents. Therefore, modern oceanographers carefully study the behavior of ocean currents. This involves using satellites, autonomous underwater vehicles, and special buoys that can drift in the ocean for years, transmitting data on temperature, salinity, and water speed. Each new measurement helps us better understand how this gigantic system works. But despite all the advances in science, the ocean remains an incredibly complex object of study. Its depths, currents, and ecosystems form a dynamic environment that is constantly changing. And sometimes these changes manifest themselves in the form of amazing natural phenomena: glowing seas, giant waves, mysterious sounds, or underwater rivers. Each of these phenomena reminds us that the ocean is more than just a huge body of water. It is a living and constantly moving system on which life on the entire planet depends. In the depths of the ocean, where constant darkness reigns and water pressure exceeds hundreds of atmospheres, there are places that resemble underwater volcanic oases. These places are called hydrothermal vents. They are located along enormous underwater mountain ranges that crisscross the ocean floor for thousands of kilometers. Here, the Earth's tectonic plates are slowly moving apart, and seawater penetrates deep into the planet through cracks in the crust. When this water reaches the hot layers of the Earth's crust, it heats up to extreme temperatures, sometimes more than 350 to 400 degrees Celsius. It is then forced back into the ocean under enormous pressure through special openings in the seabed. When underwater vehicles first discovered such sources in the 1970s, scientists were amazed by what they saw. Thick jets of hot, mineral-rich water rose from the dark seabed, appearing like enormous plumes of smoke rising tens of meters into the air. That is why such sources are called black smokers. The water flowing from these springs is so saturated with dissolved metals and minerals that it forms dark clouds of particles upon contact with cold ocean water. Gradually, bizarre mineral structures, reminiscent of underwater towers and chimneys, form around the springs. But this was not the most surprising discovery. Scientists have long believed that life in the ocean depends on sunlight. Plankton, algae, and other photosynthetic organisms use the sun's energy to produce nutrients, which form the basis of the entire marine food chain. However, hydrothermal vents are located at depths where sunlight never penetrates. However, scientists have discovered rich ecosystems around these sources. giant tube worms over 2 meters long, unusual shrimp, crabs, and mollusks formed entire colonies around the hot springs. This discovery became a real scientific sensation. It turned out that life can exist even without sunlight. These ecosystems are based on special bacteria that obtain energy not from light, but from chemicals contained in the hot water of the springs. This process is called chemosynthesis. Bacteria use sulfur compounds and other elements to produce organic compounds, which become food for other organisms. Thus, entire food chains are formed around hydrothermal vents, completely independent of sunlight. This discovery was of great importance to scientists. It demonstrated that life can exist in conditions previously thought unsuitable for living organisms. It also provided new insights for the search for life on other planets and moons. For example, an ocean may exist beneath the icy surface of Jupiter's moon Europa. If hydrothermal vents exist at its bottom, life could theoretically exist there. But even on Earth, many of these ecosystems remain poorly understood. Each new expedition discovers new species of organisms adapted to the extreme conditions of the deep ocean. Some have unusual body shapes, while others possess unique biochemical mechanisms that allow them to survive at high temperatures and pressures. Sometimes scientists find organisms that are unlike any known creature. Hydrothermal vents also play a significant role in seafloor formation. Minerals released with hot water gradually precipitate and form new geological structures. Over time, entire mineral cities of pipes, columns, and towers can grow around the springs. These structures can reach several tens of meters in height, but life around such sources can be unstable. If the spring's activity decreases or ceases, the ecosystem begins to collapse. Organisms either die or migrate to other areas where hot springs still exist. Thus, these underwater oases constantly appear and disappear. They are a reminder of how dynamic and changeable life in the ocean can be. But even hydrothermal vents are only part of the strange phenomena that occur in the depths of the sea. Sometimes the ocean can show its power not through slow geological processes, but through events that happen suddenly and can change entire coastlines. Sometimes huge masses of water begin to move with such force that waves are born that can cross entire oceans. Sometimes the ocean seems calm and almost motionless. Waves gently roll across the surface, the wind gently ruffles the water, and everything around appears peaceful and predictable. But in rare moments, the ocean can suddenly move. And then waves arise that are capable of crossing entire oceans. These waves are known as tsunamis. Unlike regular waves, which are generated by wind, tsunamis are caused by events occurring on the ocean floor. They are most often caused by underwater earthquakes. When Earth's tectonic plates shift, vast swaths of the seafloor can suddenly rise or fall, moving colossal volumes of water along with them. This movement transfers energy throughout the entire thickness of the ocean. As a result, a wave is formed that begins to spread in all directions. But in the open ocean, a tsunami is almost unnoticeable. The height of such a wave can be only 1 or 2 meters. A ship in the open sea may not even notice its passage. However, the speed of this wave can be enormous. Tsunamis can move across the ocean at speeds of 700 to 800 kilometers per hour, almost like a jet plane. As the wave approaches the shore, the water depth decreases. The energy contained within the moving mass of water begins to compress, and then the wave height increases sharply. Sometimes it can reach 20, 30, or even 40 meters. Such a wave turns into a powerful stream of water that crashes onto the coast and penetrates far inland. History knows many destructive tsunamis. One of the most powerful occurred in the Indian Ocean in 2004. An underwater earthquake off the coast of Sumatra triggered a series of waves that spread across the region. Within hours, they reached the coasts of Indonesia, Thailand, India, and Sri Lanka. Some waves exceeded 20 meters in height. Torrents of water destroyed buildings, roads, and entire cities. This event became one of the most devastating natural disasters in modern history. But tsunamis can be caused by more than just earthquakes. Sometimes they are caused by underwater landslides. Huge masses of sediment on the seafloor can suddenly collapse down a slope, displacing water and creating powerful waves. In rare cases, tsunamis can even be caused by underwater volcanic eruptions. One of the most impressive examples was the eruption of the Hunga Tonga volcano, Hunga Hapai, in 2022. This eruption occurred underwater and produced a massive release of energy. The shock wave from the explosion propagated through the atmosphere and ocean, and the resulting tsunami was recorded in various parts of the Pacific Ocean. These events are a reminder that the ocean is closely linked to the geological processes occurring within the Earth. The ocean floor is far from motionless. Tectonic plates are constantly moving, colliding, and moving apart. These processes cause earthquakes, volcanoes, and faults. Sometimes these events occur so deep underwater that they remain almost unnoticed, but sometimes the energy released deep within the Earth is transferred to the ocean water, and then the ocean begins to move with great force. Today, scientists are closely monitoring such processes. Of tsunami early warning buoys has been established around the world. These devices can record changes in water pressure and transmit data to satellites. If the system detects signs of a tsunami forming, a warning can be issued to coastal regions. This allows people to leave dangerous areas and reduce the consequences of a possible disaster. But even with modern technology, the ocean remains a force that cannot be completely controlled. He can remain quiet for years and then suddenly show his power. Tsunamis remind us that the ocean is more than just a source of life and beauty. It is also a huge energy connected with the deep processes of our planet. And sometimes this energy manifests itself in events that change coastal landscapes and the history of entire regions. Looking at Earth from space, it becomes clear what force shapes our planet's appearance. The continents appear as mere islands scattered among a vast expanse of water. Almost 3/4 of the Earth's surface is covered by ocean. It determines the climate, regulates the planet's temperature, and supports countless forms of life. But despite all this, the ocean remains one of the least explored places on Earth. Throughout this film, we've seen only a small fraction of the strange and wondrous phenomena that occur in the world's oceans. Glowing seas, underwater rivers, gigantic waves, mysterious sounds of the deep, enormous whirlpools, and invisible currents. All these are just individual fragments of a complex system that is constantly moving and changing. Sometimes the ocean demonstrates its power suddenly and dramatically. Enormous waves can appear out of nowhere. Underwater earthquakes can cause entire masses of water to move. At such moments, the ocean reminds us of its colossal energy. But much more often, its amazing processes occur quietly and almost unnoticed. Somewhere in the depths, cold water slowly sinks, beginning a multi-year journey across the oceans. Somewhere, bacteria in the darkness begin to glow, transforming the sea surface into a gigantic field of soft light. Somewhere in the utter darkness of the depths, living organisms create their own lights, illuminating a world where sunlight never penetrates. Each of these phenomena shows us the ocean from a new side. When the first oceanographic expeditions began exploring the deep sea, many scientists expected to find a desolate and monotonous world. They assumed that life in the ocean depths would be sparse and simple. But each new study brought more and more unexpected discoveries. Ecosystems have been discovered that exist without sunlight. Organisms capable of surviving under enormous pressure and extreme temperatures have been discovered. Complex water movements connecting all of our planet's oceans have been uncovered. Today, we know much more about the ocean than ever before. Satellites monitor its surface from space. Underwater robots can descend to depths inaccessible to humans. Modern sensors record the smallest changes in temperature, pressure, and water composition. But even with all this technology, much of the ocean remains unexplored. By some estimates, we've only explored a small fraction of the seafloor in detail. Vast expanses of the deep have never been seen by human eyes. This means that many phenomena that occur in the ocean still remain unknown. Scientists speculate that thousands of undiscovered animal species may exist in the deep sea. New life forms, new ecosystems, and new geological structures continue to be discovered almost every year. Each new expedition brings unexpected results. Sometimes underwater vehicles record organisms that look completely unusual. Sometimes researchers discover new hydrothermal vents or previously unknown underwater mountain ranges. Sometimes processes are discovered that force scientists to reconsider their previous ideas about how the ocean works. But perhaps the most important point is that the ocean does not exist separately from the rest of the planet. It is closely related to the atmosphere, climate, and geological processes of the Earth. Ocean currents distribute heat across the planet. They influence weather, storm formation, and continental temperatures. Marine ecosystems absorb vast amounts of carbon dioxide, playing a vital role in climate regulation. Without the ocean, life on Earth would look completely different. This is why studying the ocean remains one of the most important tasks of modern science. Understanding how ocean systems work helps us better understand climate change, ecosystems, and the processes that shape our planet. But even today, the ocean continues to surprise us. Sometimes it demonstrates rare natural phenomena that can only be observed a few times in a lifetime. Sometimes it discovers new forms of life existing in conditions previously thought impossible. Each such discovery reminds us how complex and amazing our planet is. And perhaps the most amazing thing is that many of these discoveries are still to come. The ocean remains the last great frontier on Earth. We've sent spacecraft to distant planets. We study the surface of Mars and build telescopes capable of observing galaxies billions of light years away. But right here on our own planet, beneath the surface of the water, lies a world we are only beginning to understand. And in this darkness of the depths, among slow currents and luminous creatures, the ocean continues to keep its secrets. Mysteries that may one day change our understanding of life, the planet, and the ocean itself. Because the ocean is more than just the water that surrounds the continents. It is a huge, complex, and living system. And the deeper we try to study it, the more we understand one simple thing. We are still only at the very beginning of this journey.